Okay guys, we're going to explain what happened in the Flask demo, which is when you had a flask here and it had a little bit of liquid coming out of a tube over here. If you heated the flask up with your hands, the liquid in the tube pushed away towards there, and when you cooled it down, it actually got sucked backwards towards the flask itself. The question is why? Well, it's all to do with what's actually in the flask, not the liquid itself. See, in the flask we have gas, and that gas is flitting around in there. It's got a certain amount of energy, and because of that it's moving around and it's bouncing off the walls and it's pushing each other away as it hits, and because of that the gas has a certain density, or a certain amount of gas particles in a given amount of volume. Okay? Now, that density there is going to change if you heat it up or if you cool it down. Because if you give those gas particles energy, they're no longer going to be happy to stay that given distance away from each other. They're either going to spread out or come closer together, depending on whether you give them energy or take it away. So the very first thing we did was we put hot hands around that flask. Now when we did that, we essentially heated up the gas particles, because that heat radiates from your hands into there, and the gas particles then get given a certain amount of heat, and as you do so they then decide to speed up and push themselves apart even further than what they are already. So if that heat comes in here, it heats up this gas particle, it's going to start moving even faster than before, and so on and so forth with all of the gas particles in there. They're going to push each other apart even further than they were before, and therefore they've got to spread out. Now when they spread out, there's only one way. Now you've always learnt that hot air rises. Well, that's fine when the air doesn't have a lid stopping it from rising. If it can't go up, it will bounce back down and it will find a way out of that container. If it doesn't, then what actually ends up is you build up pressure in that container. So those gas particles are spreading out, and as they do so, they are pushing that water further up the tube that way as they expand, because that's essentially what they've done. You've given them energy, they've pushed apart, they've expanded, and they've pushed the water up the tube. Now, if you put cold hands on that flask, the opposite happens. You're actually taking away energy from those gas particles. So, as they hit the side of the cold container, that energy will leave that particle, they'll slow down, they won't vibrate as much, and they will come closer together because of that. So those gas particles, the energy when they hit the side of the cold container, it will actually suck some of the energy out of them. They're going to slow down, go slower, and come closer together, and we call that contracting. So that gas in essence contracts and becomes smaller in volume, and as it does, you can't just have gaps anywhere with no particles in it. As the gas moves back into here, that water will actually be sucked backwards as well. The gas has contracted to a smaller volume, and that is why that Flask demo did what it did. See you later.